All right, shall we? Firstly, thank you all for making an appearance. It's the last official talk of the day, apart from the people that you actually turned up to see. So I understand if you want to leave the room bang on time so that you don't miss out, by all means go ahead. If Eric and I were talking at the end of my talk, I'd probably leave my own talk as well to go and see him. So I'm not going to blame you guys at all if you do. There is a 20-minute break. I'll try not to eat into that. But yeah, and if his talk starts before mine is finished, then I'll leave you guys here and you can enjoy it. All right. So, with that in mind, as promised. So, tonight, Clarkson writes Hello World. Actually, no, James May writes Hello World. Richard Hammond cleans up the mess he makes. And Clarkson does some shouting. So, all right. Now, I promised 4 slides for this talk. You've seen one. That's slide number 2. This is slide number 3. Let's go. So, what we're going to look at is an introduction to inversion of control from first principles. Now, if you're an IoC guru, wonderful, you're in the wrong talk because you should be going and listening to Phil Laureano, right? Unless you're here just to mock me or for the bribery. I see people nodding, so yeah, fair enough. Sorry, it's spinning rust in here as well, so that may take a minute. All right, so what we're going to do is we're going to write Hello World. And we're going to write the most over-engineered Hello World app you guys have ever seen. Right? So now, to set the stage, right? I have no stashed code repo here. We're going to do this whole thing from scratch, and I have no safety net. So if I cock it up in public, then you guys all get to laugh at me because I have no plan B. All right? So this has to work first time. So let's see how we go. So first things first, let's create ourselves a new solution. I'm going to go new project. That flicky is going to be so annoying. Apologies. It's going to be a console application, and it's going to be, let's say, call it topgear.app, because what could possibly go wrong with that? No one's going to sue me, right? Console app, .NET 4.5, good, done. All right, so we're going to write Hello World. And then we're going to add a little bit of logic, and then we're going to add some complexity so that it's difficult to test. Right? So the whole point of IoC is to enable the dependency inversion pattern, which we'll come to. And the whole point of the dependency inversion pattern is to allow us to make our code testable. Okay, so let's kick off. First things first. Now, I will apologize in advance. I'm going to do most of my coding. I'm going to create a whole bunch of different classes in, for the most part, one code file. That's just because it's a pain in the backside of flicking between them, and the font sizes jump up and down all over the place. So good practice says please split your classes out into their own files, but I'll leave it in here for now until it gets too complex. So what we want is a Clarkson, because a Clarkson is going to do some shouting. So var Clarkson equals new Clarkson. Clarkson dot, I'm going to say something, but he doesn't really say things, does he? He's going to shout something. And at the end of this, we're going to stick a console.read key, which will allow us to wait until our app finishes. So basically, do some stuff, and then just wait for a key press. Otherwise, we just get a little flash of the console, and it vanishes again when our program exits. All right, so we're going to create a new Clarkson object. Clarkson is going to shout something. That's going to be Hello World. So I'll enter, hey, resharper, don't fail me now. I have got a lot of code to write in under an hour. So, shout something. And Clarkson is going to do 2 things. He's going to set the console foreground color to, let's say, red. We could go for like a cool blue or something, you know, quiet and sensitive and new age. But it's Clarkson, so we're going to shout. So we're going to say console.writeLine, whoops, not window left, right line, thank you. All right, and he's not going to say hello world because that's really boring. He's going to say, you're wrong, because that's what he says. All right, so let's do some shouting. You're wrong. And let's run it. What could possibly go wrong with this? Okay, hooray! First ever Hello World by Jeremy Clarkson. He knew that he could code. All right, apologies for that font size. I'll just see if I can really quickly change the defaults on it to make it a bit bigger. But failing that, well, we'll just have to live with it. Okay, so quit that, run it again. Hooray, okay, so we can see a bit of text. All right, that's all very nice. Now, Clarkson has a few other phrases. A few, right? He's a very simple, loud man, all right? So he has a couple, right? When he's introducing Top Gear, I'm going to say it's on a Tuesday because when SBS had it and it was still cool, it was on a Tuesday evening, all right? So on a Tuesday evening, Clarkson is going to say, good evening, all right? On a Tuesday evening, at the end of the show, he's going to say, on that bombshell, and pretty much any other time he's going to say, get out of the way! Okay? Does that sound reasonable? All right, so let's add in some logic here. So let's go, if date, whoops, datetime.now.day of week equals day of week dot Tuesday, do some clever stuff, else shout you're wrong. Sound reasonable? Come on, we're a man of very, very simple tastes here. All right, so if datetime.now.hour, whoops, is greater than or equal to 1800, 6 p.m., it's about when Top Gear starts, right? And datetime.now.hour is less than 8 p.m., then we're going to do console, whoops, dot right line. Who ever uses window left? Why is that the default there? Honestly. So he's going to say good evening. All right. Else, if datetime.now.hour is, let's say, greater than or equal to 20. Let's say, yeah, that'll do. Yeah, that'll do. Console.writeLine. He's going to shout, get out of the way. Does that sound about reasonable? Okay, so it's either going to be you're wrong, it'll be good evening, or it'll be get out of the way. Okay, so no prizes for guessing what he's going to say right now.
Unless it's some other time on Tuesday.
Yeah, unless it's some other time on Tuesday, which is fine. Now, let's test this, shall we? All right, so let's write a unit test. And I'm going to let you guys think about this for a minute while I add a unit test project, but how are we going to test this program right now? So I'm going to go right click here, I'm going to add a new project. It will be a class library, Top Gear.unit tests. That'll do. Boring, boring, boring. Cool. And if you ever use class1.cs and don't rename it, you're doing it wrong. So let's just get rid of that. Okay, and I'm going to add a package reference and hopefully don't fail me NuGet cache. And unit will exist. Wonderful. All right, so you've had time to do your homework. How are we going to test this app? Sorry? Change the system clock. Bingo. Choice. Minty or chocolate? Chocolate or chocolate? Bingo, we're going to change the system clock, and that's going to be awesome. All right, incoming. Oops, sorry, that's right. All right, so we're going to change the system clock. How do we assert? How do we assert that it actually spat out the right message? Read the console. Who said that? All right. Who's? And Minty or chocolate eclair? Minty. All right. So that's crap. That's crap. We just don't want to do that. It's all too hard. So let's not. Bingo. So what we can do. Eclair or Minty? Eclair. Cool. I'm not going to try to throw that distance because if I fail, imagine the shame. All right, so what we should do is we should start to separate some of our concerns, right? So I'm going to introduce, remarkably enough, I've thought about this a tiny bit before, I'm going to introduce an auto cue. Right? Clarkson can read from the auto cue. Right? And he will just say whatever the auto cue says. Does that sound reasonable? Yeah? All right, let's do that. So what we're going to do is, in our shout something method for now, we're going to go var auto cue equals new. Sorry, I missed that guy. Can he read? Shut up about that. You're stealing my thunder. But yes, no, it's a very good question. Okay, so we're going to create a new auto cue, and then we're going to go var message equals, and we're going to say auto cue dot get something intelligent. How shameful is it that I can't spell intelligent? There we go. Okay, so we create a new auto cue. We ask the auto cue to give us something intelligent to say. What could possibly go wrong with reading from an auto cue, right? And then we say it. All right. So let's do that. So we're going to create an auto cue class. That will do nicely. Bonus points for anybody who can tell me the keyboard shortcut I just used to go back to that. Alt enter. Control minus. Other one. Took me to the red bit.
Alt page up.
Alt page up. Well done. Minty or Claire?
Minty.
Sorry?
Not Minty.
Not Minty. Here is a not Minty for you. Well done. Alt page up and alt page down in ReSharper are your friends. They say take me to the previous or next issue, whatever your issue is. Okay. So in this case, all I had to do is alt enter. Oh, sorry, alt page up, alt enter, and this is going to be a string. Get something intelligent. That'll do. All right. And now what we're going to do is we're going to extract out this logic so that we can actually test some part of it. Okay, so let's just nick this bit and splat that bit. And instead of console.writeLine, we're going to return. And I'm going to leave those parentheses there for a second because it's just way too hard to get rid of them, and then ReSharper can get rid of them for me. Return that, return that. Cool, oops. Alt enter, enter, alt enter, enter, and unfortunately code cleanup won't actually get rid of these for me. Okay, so we're going to create an auto cue. That's all very nice. We're going to get the message from an auto cue, and all that means is we're going to go console.writeLine message. That looks a little bit more testable. Kind of. So let's run a quick code cleanup on that. All right, so we have an auto cue, and that's all very nice. Now we can write a test for our auto cue class. Right? We still can't actually change the clock. Right? We still have no way of lying to our auto cue to test that sometime between 6 p.m. and 8 p.m. it actually says good evening, right? And sometime after 8 p.m. it says whatever it says, get out of the ray, or else it says you're wrong. Okay? So what we want to do is we want to allow ourselves to lie to our auto cue. Okay? And the way we're going to do that is instead of depending directly on datetime.now here, we're going to depend on an abstraction. We're going to depend on something that behaves like a clock. You know, it looks like a clock, it quacks like a clock. Tick-tock, tick-tock, right? All right, but we can lie. So let's do that. So I'm going to extract that into a variable. That'll be nice. Datetime equals datetime.now. All right, and what I'm actually going to do, actually just rename that to now. And instead of taking datetime.now here, I'm going to ask clock.now. Now we don't actually have a clock yet. All right. So what we're going to do is we're going to create a dependency on a clock. So I'm going to create a field called the clock, and it's going to be an iClock, and that's all very nice. And we don't actually have an interface called iClock either, so I'm going to create one of those. Internal interface here should be public. Cool, alt page up for me. And he's going to have a read-only property now. Whoops. There we go. Datetime now, and that'll do nicely for now. So our iClock is just going to return some form of now. Right? And that's all very nice. And then the next thing we can do is we can ask ReSharper very nicely to initialize that field from a constructor parameter for us. And off we go. All right. So we've got a problem. Let's write a test first. Whoops. Top Gear. I can't believe I misspelled Top Gear. Many apologies, guys.
Get out.
Class. I am a bad person for that. Sorry. If we weren't under time pressure, I'd actually fix that. Okay, so when reading, the auto cue, all we know is when reading the auto cue on a Saturday, there we go, public void, the message should be, and what is it? You're wrong? Yeah. You're wrong. Okay. Now, we could stick this into a string. Like, as in, we could just put it in line string here. You are wrong. What I'm actually going to do is really quickly extract these constants. Actually, I'm just going to extract this one because you get the message for the others. So I'm going to extract that to a field. It will be a constant, and it's going to be a public one. And it will be your wrong message. Now, we'd pull this from, somewhere sensible. But for now, we don't care. Okay, and we're going to nick that and drop that there. So there's our default behavior. All right, so when reading the auto cue on a Saturday, now I can go back to full screen here. All right, the message should be you're wrong. So we're going to go var auto cue equals new auto cue. Oops, view. Auto cue, resharper, don't fail me now. Alt enter, thank you very much. Okay, and we can see that it's complaining a little bit that we've not satisfied a constructor parameter. Right? We've got a little red squiggly under there saying, well, I don't know how to create an auto cue without giving it a clock, so we've got a compilation error. We'll come back to that. Then we want to go var message equals auto cue dot get something intelligent. So this is our act component of our test, and then message dot should be auto cue dot you're wrong message. And I can't live without shouldly, so I'm going to really hope that that's in my NuGet cache as well. Shouldly install, thank you very much. Close, go away. Cool. Bring back full screen. Alt enter. Cool. All right, so here's roughly what our test is going to look like. We create a new auto cue, we ask it for its message, and then we assert that the message should be something or other. Awesome. So we need to give this one a clock. Right? And I'm going to create a local variable. Now, quick show of hands, who's used a mocking framework before? Most of the room, some people haven't. Okay, that's fine. This is not the textbook way to do this, okay? I'm just going to write an ugly mock. Use nsubstitute or mock, please. If you don't know nsubstitute or mock, go Google them. All right, but for now, we're going to say iClock clock, and obviously that's going to throw a null reference exception somewhere horrible, so that's really bad. What we're going to do is we're going to create a fake clock. Public class, and it's going to be a Saturday clock, which implements iClock, and it's going to return new date time from 2012 12/01, and it's going to be, doesn't really matter, let's say 3 p.m.
1 p.m.
No, sorry, 1 p.m. that'll do. Yep. And that's it. All right, and that's you. All right, and one more. Done. All right, so we're going to create a new Saturday clock. So this is just going to be var clock equals new, one of those, paste, fix my typo. Done. Let's mark this guy as a test. Whoops. Test, thank you. And this guy as a test fixture. Make him public. Hooray! Here we go. We've created a fake clock so that we can create our auto cue. We've then asked our auto cue for some sort of message, and we've got an assertion to say, hey, the message should be whatever we're expecting. So we've made that bit testable. What we have introduced, however, is a compilation error, well, at least one. So let's find out what happens when we build this. Bollocks. Topgear.app.autocue does not take a constructor that has no parameters. Okay, fine. So in here we've got to create a new, and we're actually going to create a real one. Whoops, call it system clock. That'll do, and we're going to create that guy. Come on, resharper, don't fail me. Create class him, Alt enter, implement. Cool, and he's going to go, sorry, full screen. In his getter, he's just going to return datetime.now. What could possibly go wrong? Okay, so we've got a Clarkson. Our Clarkson is creating an auto queue, and that needs a system clock, so he's creating that for us as well. And then he's asking the auto queue to give him something intelligent to say, and then he's saying it. So, what could possibly go wrong? Right, our code's running. Sweet. Right. Let's give Clarkson one more tool. Right. Now, Clarkson's not going to say these things quietly and politely. He's going to shout them. Right. So he's going to shout them, in this case, into a megaphone. Right. So we're going to remove the knowledge.
Doesn't need one.
He may well not. All right. So we're going to quickly create a class, public class, megaphone, and it's going to have a public void shout string message. And we're going to nick this. We're going to go var megaphone, equals new megaphone, and then we're going to go megaphone.shout message, and we're going to rip these guys out into our megaphone class. And that's all very nice as well. And let's run that. Hooray! We've still got running code. That's good, because again... Sorry? Yeah, actually, that's a good point. I didn't think of that, so your choice of lolly? Minty or not minty?
The other one.
Not minty. Incoming.
Cheers.
Oh, sorry. Here you go. So where are we? Message dot to upper invariant. That'll do. That's better. Well done. Okay. Now, the problem we have at the moment is that we can test an auto queue because we can create it, right? But we can't test a Clarkson, right? If we want to test a Clarkson, all we can do is new it up and call the same method as we did in the beginning, and we've still got this opaque box of, well, what does it actually do? Right? So what we want to use is the dependency inversion principle again to say, well, rather than have a class be responsible for creating its own dependencies, I want someone else to supply them for me. Okay? Now, the reason that I sort of took the whole Top Gear topic for this talk is because I want your code to be like Clarkson. Right? Think about it. Right? Clarkson walks up. He doesn't say, oh, my megaphone's not here. I shall go and find it. Is it in the cupboard? Right? What's he going to do? Where's my megaphone? Right? Right? Where's the auto cue? He's going to shout and say, get me one. I don't care where it comes from, just get me one. Right? I don't care who gets it, get me one. Right? So I want your code to be like that. I want your code to be loud and shouty and obvious about what it's doing. Right? There's no subtlety to Jeremy Clarkson. Right? Self-documenting code is not just code that doesn't have comments, it's code that's blindingly bloody obvious as to what it does. Okay, so we want your code to be like that. So we're going to apply the dependency inversion principle to Jeremy Clarkson. Right. And if someone tweets that out of context, I'll give you a lolly. All right. So now the thing is, right, what we're newing up here, I'm just going to extract this into a variable. All right, so we're newing up a bunch of dependencies here. We're newing up, here we go. We are newing up a system clock, an auto queue, and a megaphone just in order to get a message and chuck it somewhere. So let's not do that instead. Right? So I'm going to extract this to a field. Actually, I'm going to extract auto queue to a field. Right? So you can go away. Oops, missed that. Sorry. Extract that to a field. Yeah, that'll do for now. Okay, I'm going to extract that to a field. All right, and I'm going to get rid of this guy. Now I'm going to ditch those two. And I'm going to introduce these two from a constructor parameter. And I'll run a code cleanup because I'm an obsessive compulsive person and they have to be read-only, otherwise I get confused. Okay, so now let's have a look at our Clarkson class. Right? It's really pretty obvious now, right? Our class here says, I need an auto queue and a megaphone, and I'm good. Right? Now that means that he's really easy to test because we can give him a mock auto queue, right? And we can give him a mock megaphone, and we can have the auto queue say whatever we want, right? And he'll faithfully say it back to us, right? And we can then give the mock megaphone, maybe we write a piece of code that says, whatever message you receive, I just want you to store that, and we can then compare the two. Right? So we can give him a fake auto queue that says, isn't it a lovely day? Right? And then we can say to the megaphone, did you receive a shouted message saying, isn't it a lovely day? Right? So we're testing our code flow. We're testing our data flow, actually, all the way from here where it originates through to there where it's supposed to be used. Right? And Clarkson himself just becomes the orchestrator. Problem here is now we've got to create a Clarkson. Now, we've still got a compilation error in our code, so let's have a look. Let's build this. Make it not full screen. Oh, bollocks, here we are. Right, so in our main program, we're now creating a Clarkson, and we are responsible for providing Clarkson all of his dependencies. Right? So we could do that. We could say, let's do this. What does he need? He needs an auto queue, yeah, new auto queue, which in turn needs a new system clock, and he needs a new megaphone. And that'll work. Sorry? Sorry, I missed that one.
He needs a new megaphone.
Oh, he broke the last one. Yeah, that wouldn't surprise me at all. Actually, he's shouting into it, it switches off and nobody notices the difference. Okay, so it's still working, our code's running, and if we care, our tests are probably going to pass, except that, we're not going to run them for now. All right, so what if Clarkson... Actually, no, before that, we've got a little bit of time, so I'll use this. This is a pain in the backside, right? Because everyone who uses a Clarkson needs to be able to construct one. That means everyone who uses a Clarkson needs to know about its dependencies, right? Trust me, if you create more than one Clarkson, that's going to be a scary place for the world to be in. So, what we're going to do is we're going to create a Clarkson factory. So let's do that. So what I want is instead of going var Clarkson equals new Clarkson bollocks bollocks bollocks, I'm going to go var Clarkson equals Clarkson factory dot spawn 1. That's not your normal pattern name for a factory method, just by the way. Okay. But hey, so we're going to create a Clarkson factory, and we're going to create a method called spawn1, and he's going to return a Clarkson, which is a scary, scary place to be. He can go public. All right, and in here, we're going to go return new Clarkson, which will take, remarkably enough, yoink, all of that gunk. So let's run that. Hooray, class factory works first go. Problem is, though, Clarkson's got a dependency on an auto queue. And our auto queue has a dependency on a system clock. So what if we add another dependency to our auto queue? All of a sudden, our Clarkson factory needs to know about our auto queue's dependencies. Bollocks. That's not good. Right? Because what we're going to end up with is one gigantic God object factory that knows about everything at all, and we have to change that every time we change a single one of our classes. So what we can do instead is we can say, well, rather than creating a new auto queue out of this one, copy pasty, comment him out. Incidentally, if you check in commented out code, you are a bad, bad person. Do not do this. Auto queue factory dot build 1. All right, so create a class called AutoQueueFactory. He's going to have a build 1, and remarkably enough, see, there's a reason I left that there for a second, because I can now go, oops, that's not what I wanted.
Isn't there a reshuffle key for what you want?
You remember, there is actually. jQuery, all the things. You remember the first time I typed on this keyboard was at 5 minutes to midnight last night. So I'm doing okay. All right, so how are we going? We've got a Clarkson factory. The Clarkson factory has a reference now to an AutoQueue factory, and remarkably enough, crazy as it sounds, our code is still working. All right? So this is really not fun. Right? And we're basically going to end up with this pattern called parallel hierarchies. Right? Parallel hierarchies is basically when you start with a piece of code over here and you kind of design a whole hierarchy underneath it, and you say, well, I kind of need some other stuff that's over here and pretty much completely unrelated to actually know about the shape of the stuff that it's not supposed to know about. So in this case, what we're going to end up with is whatever structure our classes take, our class factories are going to take as well. Right? Now this doesn't actually, in the long term, this just doesn't reduce the amount of work that we have to do. All it does is it adds complexity and for no benefit.
What do you mean it's a factory?
Bingo, what I need. What could possibly go wrong there? All right, so we've... Yeah, okay, point. Minty or not minty? Minty. Another one if you do the clap and the yell. Well done. Overheard Liam McLennan yelp. Okay, so our first creation scenario was a bit of a bugger. It's kind of ugly. Our second one kind of looks really nice, but then when we actually get to it, oh, that was a bad idea. What we would really like is an automatic factory. What we would really like is a way to say, you know what, I don't care about what this thing needs, just get me one! Right? I don't care what dependencies it has. Just get me the stupid thing, because all I care about is that I want to use it. So, let's do that. So I'm going to get rid of this one, and we're going to go var Clarkson equals, now we're going to say automatic factory dot get me one of type of Clarkson. Now, get me one could return pretty much anything of any type because it's an automatic factory, so we're just going to cast that back to a Clarkson just so that we're comfortable there. And let's go and create ourselves an automatic factory. Now at this point, I'm just going to go and extract all of the classes into their own files because this file's getting really messy. So let's just quickly go refactor, shove off you lot. Cool, and now this is all nice and neat and tidy again. All right, so we're going to implement an automatic factory. Create a class there, make him public. Get me one, he's going to be a public static object. Get me one of type. All right, now, who's heard of the activator class? Some, I know you have. All right. This is actually really awkward writing like IOC from first principles with the author of one of the world's most premier containers sitting in the back row glaring at me. So, and I'm going to commit a very bad sin shortly, so forgive me in advance. All right, so what we're going to do is we're going to say return activator.createInstance of type. I'm going to stick a breakpoint there. And let's run this. So we're going to say, okay, here's the automatic factory. I would just like something of type Clarkson. Get me one, please. And we're going to run it. And it couldn't possibly be that easy. And you're right, it isn't. Because what's going to happen, you see we're in our get me one method. And we've got a type for a Clarkson. And when we let this run, kaboom, it says, I don't have a parameterless constructor for this object. In other words, all of the constructors I could find for the Clarkson type need parameters. Right? So I can't just build you one. Right? You need to give me some stuff that I can build it with. So let's have a bit of a poke around in here. And what we can do, activator.createInstance also has a couple of overloads. Whoa, it has a lot of overloads. One of the overloads it has, however, is a collection of objects which you can pass as parameters to your constructor. So what we're going to do is we're going to say var constructor equals type, oops, this is the type we want, .get constructors, and I'm going to say get constructors dot single. If you have more than one constructor, I'm sorry, my automatic factory is not for you. All right. So what we're going to say here is get me the only constructor that this type has. The next thing is we're going to say var parameters equals constructor dot get parameters. Now, if the constructor method does not require any parameters, then we can just call activator.createInstance on it. Right? We can just say, all right, create one of whatever. So if not parameters.any return, oops, actually, return that. Does that make sense? Yeah? If it doesn't have any constructor parameters, then yeah, we can just create one. Great. Let's do that. However, if it does have parameters, then what we need to do is we go var args equals new list of object. Oops. Sorry. Not that it matters, but it kind of does. For each var parameter in parameters, we'll go var arg equals, now let's just do this again, and we say activator, create instance of type parameter, dot parameter type. That's all pretty good. And then we're going to go args.add, arg, and then down the bottom we're going to go result equals activator dot create instance of type, and we're going to give it our arguments collection. And return, go away you, and return that. So here's our automatic factory. Bingo for you. Lolly or Minty or not Minty?
Not minty.
Not Minty. Incoming. Right, so the problem that we have here is that this is going to work for one level of dependencies. Right? What we run into is, it's all very nice, but what happens when the thing that I'm creating, like an auto cue for a Clarkson, also has a dependency, being a clock? Okay. Now, I'm going to quickly unload my test project because I'm going to break all of my tests and I don't want you to see it. Okay. And I'm going to cheat really, really badly, and I'm going to change this guy to take a dependency on a system clock. And I don't think we've got any others. Clarkson needs those two, they're concrete types. Cool, and we're good. All right, so let's run this. Let's see what we get. So we're in our getMe1 method. We've been given the type Clarkson. Okay, that's all very nice. Get me the constructor. Okay, and the constructor we can see takes a couple of parameters. One is I want an auto cue, and the other one is I want a megaphone. Okay. So we can't do that. Okay. When we get to, and I'm not going to step through this because we don't have enough time and I want to actually do it first time and have it work. But the problem is when we get to activator.create instance on an auto cue, that's going to go bang. Because we're going to have exactly the same exception saying that our auto cue doesn't have a parameterless constructor. So, lolly from earlier, instead of saying activator.create instance, hey, we're going to say, remarkably enough, we've got a method already that gets me one of whatever I want, and that's this guy. We're going to call ourselves. How's that? Is that going to work? Let's find out. What could possibly go wrong? So let's run it. Now, have a look at our call stack. We are in our main chunk of program. Here we go, main class here. We've got var Clarkson equals automatic factory.getMe1, and we're one frame into our call stack on getMe1. So our parameter here is Clarkson. So let's find out. Get the constructor, get the parameters. The parameters say we need an auto cue and we need a megaphone. So let's step through each of the parameters. So this parameter, we need an auto cue. Step, and we're going to call back in to get me one. Now this is our next call down, our next stack frame down, and our parameter here is now an auto cue. Right? So what we're saying is, I don't care how, just get me an auto cue. So let's have a look. Get me the auto cues constructor, get me his parameter collection. He needs a system clock. Right? So we need to step through this. So for each parameter and parameters, now there's only going to be one of these, and hooray, guess what? Step in. We are now 3 frames deep into our call stack, and we've been asked for a system clock. So let's have a look. Get me the constructor, get me the list of parameters that that constructor needs. It doesn't need any. Hey, guess what? We can just return a system clock. So now, we're 3 frames in. Step, we are now 2 frames in, and we have a functioning system clock. Not bad. Now, we add that to our args collection. We step through here again. All right, and we say we need an auto cue, and we're going to give it a system clock. Here is our auto cue. Return that, count the call stack frames. Steppy, steppy, steppy. Cool. There's our auto cue. We're going to add our auto cue to our args collection. We're going to step through this guy again. Now we need a megaphone. So we're going to step into here, and same deal. Get me the constructor for the megaphone. Get me the parameters required for that megaphone. It doesn't need any. So we're just going to return straight one of those out. Count the call frame, the call stack frames again. now we have an arg containing a megaphone. Let's add that to our args list. We've finished our for each loop. We have a type. We're going to create a Clarkson. We have 2 arguments, one of which is an auto cue, one of which is a megaphone. We're going to create that. Worked first, go. Do I get a lolly for that? Only a minty. Okay. So how's that? Now, we've got a couple of problems here, right? But let's go through a couple of problems that this approach solves for us. Now, our little clever clogs up the back there, who was stealing my thunder and therefore doesn't get a lolly for it, right? What if Clarkson can't read without his glasses? Right? What if Clarkson now decides, I'm getting on a bit, can't see that auto cue, right? BBC's too cheap to buy a bigger one, get me some glasses. Right? Notice he doesn't go to the store to buy some glasses, that's ridiculous. He shouts and someone brings them to him. Right? So, let's say Clarkson needs some glasses, and what he's going to do, where's our Clarkson? Right, so here's our Clarkson. Here, he's going to say, I need some glasses. There we go. Now, shout something. He's going to get a message here. He's going to say var readable message equals glasses.read message. And actually, let's not call it read because that's really dodgy. Let's say magnify. Not that it really does anything. We're going to cheat, remarkably enough. We're just going to return that. Okay? The point of this is not that we actually want to do anything. The point is to just introduce another arbitrary dependency. So we've changed our Clarkson constructor signature. Right? Let's say we've got unit tests around our Clarkson entity. Right? Every single one of those tests that construct a Clarkson will need to change. Not only that, every single place that we use a Clarkson in our code is going to need to change, or will it? Let's see. So we've got our Clarkson factory. So if we'd had our old approach, we're stuck. Every single time we introduce another dependency, we have to manually create these. Right? Now, we're not actually using the Clarkson factory anymore. So I'm going to go comment him out, throw new not implemented exception. Oh, wow. I've somehow managed to move to a UK keyboard map. This is going to be funny.
It's top gear, please.
Seriously, I've got no idea how I managed to do that, but I actually have a UK keyboard map on here right now. So this is going to end really, really interestingly. Okay, so to this build. All right. Now, we've just removed our implementation there, but our actual factory, if we just... I'm not going to step through that horrendous recursive call stack for you again. Hey. Didn't have to change a thing apart from the factory that we're deleting. So, what this allows us to do is arbitrarily change our constructor signatures, arbitrarily change our dependencies that we need in order to do our job. Now, this isn't just adding dependencies, but this is also going to help us when we decide, actually, you know what, this class is way too big, and we should remove some dependencies as well. It's exactly the same problem. We're going to remove some dependencies from the constructor, right? And we don't want to have to go through and redo all of our plumbing just for that. Now, that's all very nice. You would have noticed that seriously, I've got no idea. English, UK, US. Okay, there we go. All right. And I'm going to delete our Clarkson factory again because that's really ugly. Go away you. And our AutoQ factory because you can go away too. All right, cool. So, problem is, earlier I unloaded our test project. Why is that? Bingo. Minty or not minty? Not minty. I'm not using interfaces anymore, so if I reload that project and build it, oh, bollocks. Right. My AutoQ doesn't take a Saturday clock. It needs a system clock. Right. Okay, fine, not a worry. Resharp it to the rescue. Change type of parameter of called constructor. No, that's not what I want. I want him, and I want him to be an iClock. No worries. My tests will pass. They should. Let's find out. We never actually ran our tests before, but they should pass. If not, no matter. Come on, chug, chug, chug. Hooray, test still passed, that's all good. All right, so our tests are passing, ship it. And it's all gone horribly wrong. It's gone horribly wrong, why?
You can't construct up an interface.
Bingo.
Not minty.
Not minty? All right. Incoming. Oh, sorry, bad. All right. So what it's saying is, I'm sorry, but this interface doesn't actually have a constructor. Twit. Of course it doesn't. Of course it doesn't. You're not allowed to construct an interface. It doesn't make sense. So what we have to do is we have to decide on the type that we actually wanted. So let's get this. Now I'm going to use a resharper trick here and extract a variable. Replace 3 occurrences, thank you very much. And I'm going to say var type we actually wanted equals type. Right? Which isn't very useful by itself, except that then I'm going to say equals figure out which type we want for that. All right, and I'm going to create a method for that, and he's going to be a type blah blah blah, and he's going to go return type of program dot assembly dot get exported types dot where type goes to type dot type is assignable from t, where t goes to not t is interface, oops, where t goes to not t is abstract dot first. Now resharper is going to whinge and say I should change that a little bit to return first of that disgusting where clause, but I'm not going to. And I'm actually going to tell resharper to be quiet. All right, so what we're doing, and I will let it replace that one with the method group. So what we're doing here is we're saying figure out which type we want. And that's going to be all of the exported types of this assembly, the assembly that contains our program class, this one, right? Where the type that we've been given is assignable from that class, where the type that we're iterating through is not an interface and is not an abstract. In other words, I'm allowed to create an instance of this thingy, and this thingy implements the interface that I want. So, and there are all sorts of really nice extension methods out there to do that check a little bit more easily. Boom, works again. Do we want to step through that? Yes, no? No, okay, cool, not a worry. So, let's have a look back at our scenarios here. So the first one, we can now probably agree that's a really muppet way to do it. Right? We can agree that the second one kind of looks all right, and it's a bit, whatever, but it becomes really, really nasty. And this one's kind of cool. Right? I'm just going to add a quick overload to that, comment that out, copy that, and I'm going to say automatic factory.getMe1 of type Clarkson, because we like generics, and I'm going to create an overload, public static t get, t get me one of type t, and we're going to return out of this get me one, whoops, of type of t, and we're going to have to cast that back to a t. There we go. Now I'm not going to bother running that, but we're pretty good here. All right, actually we will run that really quickly. Great. Done. They're wrong. Done. Now, remarkably enough, this is all very clever and whatnot, but wouldn't it be nice if there were already some form of automatic factory that we could use? Yes. I have just written one. And you get local packages. Hey, an automatic factory. What do you know? Who'd have thought? So now what we're going to do, var Clarkson equals, now we're going to resolve this from our container. So we're going to go container.resolve Clarkson. I am sorry in advance for people who know what I've just done there. I'm a very bad person. For people who don't know, just don't copy that bit. Okay, and what we're going to do as part of our setup is we're going to go var container equals let there be IOC. All right, and we're going to do that. He's going to return an I container.
That's more multi-thread, much easier. Yours is more optimized.
Yeah, absolutely. And mine's faster and clever and all the rest of it. I'm so glad Nick's not here to see that. All right. Sorry?
It's more fun to write.
It's more fun to write from the beginning. You just wait until I get into memory leaks. All right, so return. Now, we're going to go var builder equals new container builder. Return builder.build. And we're going to go builder.register assembly types, type of program.assembly, dot as implemented interfaces, dot as self, whoops. Not that it really matters because we haven't actually discussed scoping yet. All right, so now what we've got is a proper automatic factory wired up. There's your IOC container. That's what IOC is. Right? So IOC is, it's a bit difficult to draw the distinction between IOC and DI. DI is the design pattern. DI is the pattern and practice of explicitly taking dependencies on whatever you need via either constructor parameters or properties or whatever. IOC is really regarded as the automation of that sort of approach. Now, you'll get into religious wars on this, okay? So basically, people use DI and IOC interchangeably. Don't start another one, okay? We have enough religious wars to go around. So, what we have here, we're creating a container, and we're telling it, register all of the types in this assembly, right, as the interfaces that they implement, and as themselves. Right? So we're going to go scan through a system clock, and we're going to say, well, you're a system clock, so if someone asks for a system clock, they can have you. And you implement iClock. So if someone asks for an iClock, they can have you. Right? Notice that we didn't extract an interface for our megaphone or our AutoCue or our Clarkson. We should have, but we don't have time to do that. So we're resolving Clarkson directly from here.
What happens if you have a class that has a constructor with a value type?
Ask me that afterwards. You can use a delegate, like an actual factory delegate. So you can say, here's a delegate, it's a public signature, and it just includes the value type that it needs, but then the constructor can have all the other dependencies as well. As a general rule, if you follow this sort of pattern from the beginning, you don't end up with classes that need that. But that said, if you need it, it's there. But yeah, if you're curious about that, ask me after. Now, we've started from Hello World. We're finished with Hello World. Presumably all our tests pass right now. All right. A few other things that IOC will do for us. Right? And we've got about 3 minutes left, so we're doing pretty well according to time. Right? I've done a really, really bad thing here. What I've done is I've resolved a Clarkson from our root container. Right? Now, our automatic factory only took care of one component of what an IOC container is going to do for us, and that's the actual construction of an object. Now, when you get down to it, constructing stuff is actually pretty easy. We can leave stuff strewn all over the landscape, and no one cares until our garbage collector goes, hey guys, I give up, and we get an out-of-memory exception. Right? What our IOC containers will do for us is they will track the lifetimes of our objects as well, and they'll dispose of them. So if you look at this one, where I've said, register all of these as the interfaces they implement as themselves, I want you to register it as an instance per lifetime scope. What that says is, come to what a scope is, but when I create a scope and I resolve stuff from within that scope, when that scope goes away via iDisposable, everything that I created within that scope also goes away. So I'm not going to do the whole thing, but if we were to make Clarkson, actually let's do that. Let's make Clarkson implement iDisposable really fast. Oops. Import type, implement him, and dot shout. Oh bugger, it's changed to freaking UK again. We have one last party trick. So we're going to do that guy. Now we're going to say, instead of var container, so var thing is there, we're going to go var, oops, using var scope equals container Begin lifetime scope, I'm going to resolve a Clarkson. And then I'm going to say Clarkson.shout something. I'm going to comment him out because he still needs to exist for everybody else. Right? And what we should see is that our Clarkson's dispose method has also been called. Now we can nest that as much as we want, and it will tidy up after us. Not quite gone on memory leaks, but certainly if you use this, you use your managed composition, plus you use your lifetime scope management, then you're in a pretty good place right now. So if we come back to this, every single one of these classes can take dependencies just on interfaces. Every single one of these classes can therefore have all of their dependencies mocked out, stubbed out, whatever, using your favorite mocking framework or just a lying Saturday clock. Right? Every one of these is now testable in isolation. Right? We can unit test our code, not integration test our code. Right? We can be confident that every component is operating well by itself, and if we break something, then we've got a pretty good guess at where it's gone. Right? At the beginning, if our Clarkson wasn't giving us the right behavior, then we're just stuck. But at the end, we've got tests for each one of these individual little components. If one of those tests breaks, we know exactly where the component's broken, and we can fix it really fast. Does that make sense? Cool. So, on that bombshell, good night. Thank you, everyone.